Greeting to Dr. Afika Rahim. We are from Group 14 and this is our presentation for the second experiment for G4, which is the Smith-Hammer test. So we are consist of 5 members, which are Atira Balkis as our leader, Clarifa Clara, which is me, Kate Dennis, Muhammad Danish, and also Rachel N. Jastri. Moving on to the introduction of Smith rebound hardness test. So basically this test is a rapid, non-destructive testing method to indicate the compressive strength commonly applied on rock or concrete. But for this one experiment, we will test it on rock. This test considered as rapid because the test does not require laboratory regulation, which makes the test the most convenient to be used on the field, even with low expertise. Plus, it is considered as convenient because we only need one apparatus, which is the sledgehammer itself. Moving on to the principle of Smith rebound hardness test. So the principle itself propose that the rebound of an elastic mass, generally depending on the hardness of the rock surface against which the mass had struck. This is basically referred to the mass that was applied on the plunger within the tubular housing. As you can see, the sledgehammer has this spring at the middle of the tools, and this spring is the one which will control the mass that was applied on the plunger. And when we test it on a specimen of rock, the result will shown on the Smith-Hammer through the rebound index. Thus, based on the principle itself on point 2, we will have a clear idea about the relationship between the hardness and the compressive strength along with the elasticity. Just like what the third point tells us, that the hardness of the rock specimen and the rebound hammer readings are corresponding with the unaxial compressive strength, UCS, and the modulus of elasticity, E, of the rock itself. So, moving on to the objective of the experiment, there are two main objectives that we want to determine in this experiment. The first one is to indicate the type of hardness of the rock based on the ISRM standard. And the next one is to determine the unaxial compressive strength, UCS, of the rock. The next one is about the apparatus that required to undergo this experiment. So basically, since this experiment is a rapid test, so for laboratory requirement, we only need these two apparatus. The first one is the Smith-Hammer itself. We are using type L with impact energy of 0.74 Newton meter. And the next one is sample cradle made of steel. These apparatus are used to hold the rock specimen when doing the testing. So the minimum weight of the sample cradle is 20 kilogram.
For the data type, as you can see, there's two tables, which is table rebound hammer and table rebound, and the table average rebound and UCS value. So for the data, we have the reading and the rebound value data are given, and then we have to find the UCS value, which is uniaxial compressive strength. So how do we obtain this UCF is through this graph. So we have to determine the granular diorite unit weight, which is 2.67 times 9.8. The formula is density times speed of gravity, and 2.67 we obtain from the internet the density volume for the granulometeorite of igneous rock. And then after we calculate, we got 26.19 and run up to 27. And from the graph, we measure from the rebound hammer value, for example 30, and we bring it until 27 unit weight, and we bring it to the y-axis, which then we will be obtain 50 unit axial compressive strength. After we obtain for the 9 readings, we will calculate the average rebound value and the average unit axial compressive strength. Thank you.
For this experiment, you will need a rock specimen with a flat surface, the Smith hammer, a clamp stand, as well as a rigid base. The rigid base is to prevent any movement from the rock during the experiment. So, first the rock specimen will be placed underneath the clamp stand, and then the Smith hammer will be calibrated for each process. After calibrating, the Smith hammer will be placed vertically downward and pressed down onto the rock specimen to obtain its rebound value. The process is then repeated 9 more times for us to obtain an average rebound value.
For the discussion, Schmidt hammer is used to estimate the strength of the rock specimen and for comparative investigations. The higher the rebound number indicates the stronger the rock is. From the experiment, the density of the rock is 27 kilonewton per meter and the average rebound number is 38, while the average UCS value of the concrete is 83 MPa. As for the conclusion, since the UCS value is located in between the range of 50 to 100 Newton per millimeter square, according to the ISRM standards, the rock is strong and it has low-grade metamorphic rocks, marbles, some strongly cemented sedimentary rocks, some weathered and metamorphic igneous rocks.
As for conclusion, the experiment is a success as the objectives has been achieved. The rock mass quality for core line 1 is excellent, whereas core line 2 is good and core line 3 is fair. Higher RQD indicates a higher quality rock mass, while a higher CR indicates the cores are more likely to be intact in one mass.